Hello YouTubers, welcome to my channel. Today I'm going to be teaching you on the EOQ model with discounts. I have done another video on the EOQ models. If you have not watched it, please do so that you can get more content on the how to get the EOQ, the total cost, the carrying cost, the ordering cost, how to get those formulas and calculate them, and so that we will be able to do this lesson today with a much more knowledge of the previous lesson. And viewers, if you've not subscribed to my channel, please do so by hitting the red subscribe button so that you can continue getting more notifications on the videos that I post. If you like the videos, please like them, share them, and comment on them so that the channel may continue growing. We are trying to get to 1,000 viewers by the end of July, so please do so, and let's enjoy today's lesson. And so we are saying, where the replenishment orders are sufficiently large, suppliers may offer purchase price discounts in two levels. That is the single price discounts and the discounts at several price levels. We are going to look at the single price discounts. Here we compare total cost for optimal inventory policy without discounts with the total cost if the discount is accepted. We will let the Q star be the optimal order as a policy and Q be another order size that attracts a discount. So we are saying that TC when Q is optimal is going to be CO times D all over Q optimal plus CC times Q optimal over 2 plus DP. That is when we don't have a discount. And then TC when Q has a discount is going to be CO times D all over Q plus CC times Q all over 2 plus DP. That is when there is a discount. There's a disclaimer there that if TC with the discount is less than TC optimal, then the rule is to accept the discount offer. Let's look at an example there. We will use the previous example. So viewers, as I've said, if you've not watched that video, please do so, because we are going to use the data that we had in that previous example to calculate the various aspects of this question. As you can see, we are told that suppose a discount of 2% is offered at the normal price of $500 per unit for a purchase of a minimum of 20 units. So we are saying that discount is going to be 2% times 500, which is 10. To calculate the total cost for both scenarios, there's a T table there. On the left hand side, we have total cost when Q is 20 units, and on the right hand side, we have total cost when Q is 12 units. In that video about the EOQ, please make sure you watch it. We had said that we had calculated the EOQ to be 12.08, but here we have rounded it off to be 12 units. So please watch the video to know how we got 12 units. We are saying that, let's start with the left hand side. We are saying that purchase cost is going to be 365 times 490, and 365 is the demand for the year. So we get that the purchase cost is going to be 178,850. How we got for 490 is by subtracting the normal cost less the discount. Ordering cost is going to be 20 times 365 over 20, which is 365. And the carrying cost is going to be 100 times 20 all over 2, which is 1,000. And when you get the total cost, when you calculate the total of those three costs, you're going to get the total cost as 180, 215. On the right hand side, we have that the purchase cost is going to be 365 times 500. In this case, we're using 500 as the normal price because we do not have a discount here. And the purchase cost is going to be 182,500. The ordering cost is going to be 20 times 365 all over 12.08, which gives you 604.3. And the carrying cost is going to be 100 times 12.08 all over 2, which is going to be 604. When you add those costs, you're going to get that the total cost is going to be 183,708.3. So we are saying that since TC when Q doesn't have a discount is going to be less than TC when Q is optimal, then we accept the discount. We can see that 180,215 is less than 183,708.3. So in this case, we accept the discount. Then we move on to the next one. When you have the discount at several price levels, we have an example there. Aga Khan Hospital buys a certain antidote from a large supplier, which can be bought at the following prices. We have the quantity and the price per unit in dollars. When the quantity is between 1 and 4,999, the price is going to be 2.75. When the quantity is between 5,000 and 9,999, the price is going to be 2.6. And when the quantity is 10,000 and above, then the price is going to be 2.5 per unit. Then it continues to say that the demand for the drug in the hospital is 50,000 units per year. There's an order cost of $50 per order and a holding cost of 20% of the cost of the item per unit per year. We are required to determine the optimal purchasing policy for the hospital. So the solution, number one, we are going to find the EOQ when Q is optimal for the lowest price level. And you'll say that the lowest price level is going to be 2.5. So the EOQ is going to be 2 times 50,000 times 50 all over 0.2 times 2.5. And then you get the square root of that, which gives you that the EOQ is 3162 units. And then we go to the next step, compare Q1 to the quantity required for the respective price break. If Q1 optimal is greater than this quantity, the problem is solved, but if it is less, the solution is not feasible and the search continues. In this case, Q1 is not feasible. So we have said that Q1 is 3162 units. In the question, we had been told that at a price of 2.5 per unit, the quantity was 10,000 and above. 3162 does not lie in that range, and that is why we are saying that it is not feasible. Then we go to the third point. Select the next higher cost item and calculate the EOQ, that is EOQ2. And we are saying that the EOQ is going to be 2 times 50,000 times 50 all over 0.2 times 2.6. Then you get the square root of that, which gives you that the EOQ, that is Q2 squared, or at Q2 star, is 3101 units. So we compare Q2 to the range that is required for the equivalent price. Since Q2 is not within this range, the solution is not feasible and the search continues. We can see that the range where the price is 2.6 is 5,000 to 9,999, and definitely 3101 does not lie in that range. So we continue with the search. We look for EOQ3, where we are saying that EOQ is going to be 2 times 50,000 times 50 all over 0.2 times 2.75, and we get that the EOQ is going to be 3,015 units, that is EOQ 5. You will notice that in this case, the only thing that is changing is the price when we are calculating the EOQ. Everything else is just the same. And we're saying that since the Q3 is within the appropriate range for the price, then it is a feasible solution. You will see that the EOQ3 is lying between 1 and 4,999, and that is why we are saying that it is a feasible solution. So we go to the next step. We are going to compute the total annual cost for the feasible EOQ and compare this to the total annual cost for each of the minimum quantities. So we start with the feasible EOQ, which is 3,015. Then we look at TC when Q is 5,000 units and TC when Q is 10,000 units. When you go back to the question, you'll see that 5,000 is the minimum of that range and 10,000 is the minimum of that range. That is why we are using them to calculate the total cost. So we look at TC when Q is 3,015 units. We see that the purchase cost is going to be 50,000 times 2.75, which gives us 137,500. The ordering cost is going to be 50 times 50,000 all over 3,015, which is going to be 829.19. The carrying cost is going to be 0.2 times 2.75 times 3,015 all over 2, which is going to give you 829.13. So the total cost when Q is 3,015 is going to be 139,158.32. Then we look at the total cost when the Q is 5,000 units. And so we are saying that the purchase cost is going to be 50,000 times 2.6, which is 130,000. Then the ordering cost is going to be 50,000 times 50 all over 5,000, which gives us 500. We look at the carrying cost, it's going to be 0.2 times 2.6 times 5,000 all over 2, which is going to give us 1,300. And when you calculate the total, we are getting the total cost as 131,800. We look at the total cost when Q is 10,000 units. We are saying that the purchase cost is going to be 50,000 times 2.5, which is 125,000. Ordering cost is going to be 50 times 50,000 all over 10,000, which is 250. And the carrying cost is going to be 0.2 times 2.5 times 1,000 all over 2, which is going to give us 2,500. And when you calculate, the total cost is going to give us 127,750. When we look at those total costs, we see that the least is going to be when the quantity is 10,000 units, because the total then is 127,750. We compare it with 131,800 and 158.32. So we see that 127,750 is the least, and that is why we are saying that the hospital should make orders at 10,000 units and above, since this minimizes the total inventory costs. In an organization, one of the main objectives is to try to minimize the costs. So the best option for the hospital is to buy when the cost is minimal. And that is when you're saying that when Q is 10,000 units. Again, viewers, you will see that we have gone direct to solving the purchase cost, the ordering cost, and the carrying cost. I would advise you to go back to my video to watch it so that you will get the formulas of the purchase cost, the ordering cost, and the carrying cost, so that you will understand how we got these figures. If you haven't subscribed to my channel, please do so by hitting the red button. Like, share, and comment my videos so that we can continue learning more, so that we can continue improving our grades and enjoying the lessons. Thank you very much, viewers. See you in my next video. Join my Facebook page. It's also called Economics and Maths Made Easier, so that you'll be able to know when I will be posting more videos, so that you can also interact with other members in the group, and so that we can continue growing together.